This is Professor Rogers. This presentation is the first video in a two-part series on ordinary least squares regression, or OLS regression for short. We look at how the equation of the line is determined and where we find it in output in SPSS and PSPP. We use simple OLS regression when we want to establish the linear relationship between two numeric variables. I continue the example discussed in the video, An Introduction to the General Linear Model. This data is state-level data. The log of the violent crime rate is the dependent variable, and the poverty rate is the independent variable. Pearson's R is 0.39, which indicates a moderate positive relationship. As the poverty rate increases, the violent crime rate also increases. In SPSS, the procedure running the output is found using the path Analyze, Regression, Linear. In PSPP, the path is the same, only there are fewer commands associated with regression. The output between SPSS and PSPP is so similar that I show only SPSS output in this video. Here is the command Dialog Box. The log of the violent crime rate is toggled into the box marked Dependent Variable. The poverty rate is toggled into the box for independent variables. Here is the output. We get 4 tables. The parameters of the line are found in the 4th table labeled coefficients. The first line labeled constant is the values for beta naught, the y-intercept. The second line is beta subscript 1, the values for our independent variable poverty rate. This line is most important because it contains the information we want about the relationship between the poverty rate and the violent crime rate. The first column of numbers contains the betas for the equation. It is appropriately labeled with the capital letter B. By simple substitution of the betas in the equation for their actual coefficients, we get the equation of the line. We replace beta naught with 5.097 from the constant line, which normally one would round to a more reasonable number. Here I rounded the coefficient to 5.1. Beta subscript 1 is substituted for the poverty rate, which is 0.046, and here rounded to 0.05. Thus the equation of the line is determined to be 5.1 plus 0.05 times poverty rate. We can plug in the poverty rate for each state and get its predicted value using this equation. The importance of this point to our understanding of the model's performance is discussed in the second video in this series. Here's the equation for the slope in a regression analysis. The slope is a fraction with the covariance of x and y in the numerator and the variance of x in the denominator. It's an asymmetric measure. The x and y values cannot be substituted. If we did, we would get the same result for the numerator, but the denominator would turn into the variance of y rather than the variance of x. Thus, it matters which variable is named dependent and which is named independent, unlike the situation with Pearson's R, where we get the same result either way because of symmetry. The slope can also be determined by multiplying the Pearson's R for x and y, here symbolized R, with the subscript xy by the ratio of the standard deviation of y divided by the standard deviation of x. The slope gives us both direction and magnitude. The sign of B1 is the direction of the relationship. B1 has a magnitude, but it is unstandardized. The slope tells us that the direction is positive, that is, the log of the violent crime rate increases as poverty increases. The unstandardized magnitude is the rise over the run. The log of the violent crime rate increases 0.05 for every percent increase in the poverty rate. We know from the theory of sampling that the means used to determine the slope vary between ranges of numbers known as 95% confidence intervals. This variability then undergirds the beta coefficient as well. The standard error of the beta is reported as part of the output. The beta is converted to a standardized number in the highlighted column. SPSS does not report a standardized beta for the y-intercept, but does for the slope. The standardized beta is 0.39, and the general rule for interpreting standardized coefficients applies. Thus we can conclude that the relationship between poverty rate and the log of the violent crime rate is both positive and moderate. Note that the standardized beta for poverty is 0.39, the same as the Pearson's R for the relationship. This similarity is not a coincidence. When there is only one independent variable, the standardized beta and the Pearson's R are the same. Jump to the last column. The statistical significance is recorded here. The null hypothesis for both the constant and the coefficient for poverty rate is that they are 0. Both p-values are less than 0.05, which indicates statistical significance. The 0.000 for constant is confusing. Some students mistakenly interpret this number to mean no statistical significance, but this interpretation is incorrect. It means an extremely high level of significance. 0.000 is as far below 0.05 as one can go, indicating that the value 0 is far into a tail of the distribution. In between the standardized beta and the statistical significance is t. This t is the same student's t with which we dealt when discussing confidence intervals and t-tests. It here represents the value t must take for the null hypothesis to be accepted. As we learned previously, these values are way above 2, which indicates that the results are statistically significant. This discussion looks at the determination of the equation of a line using simple ordinary least squares regression. 3 elements of an inferential statistic are present: direction, magnitude, and statistical significance. Specifically, we found a moderate positive relationship between the poverty rate and the violent crime rate. The unstandardized beta can also be interpreted as a magnitude, the rise of y over the run of x. But as we see in this case, the results are not intuitive because of the logging of the dependent variable. Thus, unstandardized magnitudes are often ignored in discussions of statistical results.